All right, advanced math day, we've got lesson 9.2.2. We're going to graph linear and nonlinear inequalities. So we're just going to add to our graphing inequalities a little bit here and add some stuff that's not aligned. So we'll get to a little bit of our exponential functions that we've done before and just see how the inequalities affect those types of functions. So here we go. We've done this one before. Got something basically like it. We're going to graph this linear inequality. We're going to go down 3 because that's the Y-intercept. 1, 2, 3, boop, right there. And then our slope is negative 5 over 3, so that means I'm going to go down 1, 2, 3, 4, 5, and over 1, 2, 3. So there we go. So I can go down 5 and over 3, or I can go up 5 and 1, 2, 3, 4, 5, and then just go in the other direction, go to the left. 3, not 2. All right, there we go. Okay, so this one, we have the equality sign here, so it can be equal to. So we said on our last lesson that this would be a solid line, and the solid line represents that these are all solutions of the inequality. So if it's on that line, it works for the inequality. Okay, now I'm going to look at this sign here. It says that y is greater than. Well, when is y greater than? Y is greater than up here. So I can go to any x value and then just kind of point up. Here I've got x equals negative 2, so y is greater than up there. So all along here, this should be where my solutions lie. So since the line is solid, those are solutions. And then in the shaded area, those are the solutions. Okay, part A says, what's the minimum number of points to test to know where the shaded region is? All you need is 1. So if you have graphed your line correctly, seriously? All right, that was fun. So if you've graphed your line correctly, you only have to test 1. Let's say that I tested something over here. It would have shown that it's a false statement. So then I would have known, oh, so it's this part that's a true statement. Or let's say that I test 0, 0. Plug in 0, I get 0 is greater than negative 3. That's true. That's all I would need to test because then I would know that everything up in that region would be an answer. Why is 0, 0 convenient? Because it gets rid of the variables. Okay, the variables just go away. They become zeros. Okay. Because it gets rid of the variables. Yeah, we'll do that. So because it gets rid of the variables and their coefficients. Gets rid of variables. Can't write. Variables and their coefficients. All right. So if I plug in a 0 here, well, the variable's gone away. If I plug in a 0 here, this becomes 0, and the coefficient is also ignored. So basically, if we plug in 0, 0, all we have to worry about is this negative 3 here, and I've got a 0 over there. So 0 is greater than negative 3. Yeah, good, easy. All right, why would negative 3, 2 not be helpful as a point to test the solution? Let's see where negative 3, 2 is. 1, 2, 3, up 2. Negative 3, 2 is on the line. That's why it's not helpful. Because if it's on the line, we already know the line works. We want to know if the regions work. So we need to pick a point in the region. It is on the line. And I know you guys don't want to test. Like not take a test, but you don't want to test your points. You probably need to. Just double check by plugging it in. 0, 0 is a great one to try. Unless your line goes through 0, 0, and then you got other problems. All right, let's do this next one. So now we've got y is greater than 4 times 0.5 to the x power. Okay, so this is exponential, but all the stuff that we've been doing already works with this as well. and it kind of follows the same exact pattern of what we've been doing. So let's say that, yeah, I'll put it over here. This feels good. All right, so the A value is 4 in this one. So my first point, I would go up 1, 2, 3, 4. Here's my A value. This is 0.5, which means it's 1 over 2, which means my multiplier is 1/2. So if I go over 1, this 1, 2, 3, 4. I didn't even put it in the right place. It's supposed to be right here. Ignore this one. All right, so 1, 2, 3, 4. Yeah, it's right there. All right, so there's 4. So then if my multiplier is 1/2, if I move over 1, we're going to go down to 2. If I move over another one, we're going to go down to 1. Half of 1 is 1/2. Half of a half is 1/4. 1/8, and so on and so forth. Now, if I go the other direction, I'm multiplying by 4. So 1, 2, 3, 4, 5, 6, 7, 8. So there's a point over there. And so looking at this one, it can't be equal to. So I should be making this into a dotted curve. So we're going to dot this thing. All right, so dotted because those can't be solutions. Now I have to ask myself, where does y get bigger? Because it says y is greater than. Well, it gets greater than over here. There's where the y is getting bigger. So it looks like I'm going to shade all of this section. And even this little section over here. Okay, so we need to test. But again, 0, 0 is a good one to test because we're expecting it to come out false. So if I plug in 0, 0, this becomes 0. Anything to the 0 power is 1, and we get 0 is greater than 4 times 1, 4. That's false, which is what we want. 0, 0 is in the section that should not be a solution. So I should be getting a false statement here. And so now I know that I've done the correct shading over there. All right, so all of our solutions are in that area there. All right, moving on. Graph each of the following. Y is less than 4 times 1.15 to the x power. Okay, it's not as nice of a number, but it doesn't mean it's not going to work. I usually do some black. Let's do black right here. All right. That feels good to me right there. All right, so our b value is greater than 1, so this one should be an increasing function. So 1, 2, 3, 4. All right, this should be an increasing function, so I'm just going to take out my calculator and do 4 times 1.15. All right, 4 times 1.15. I get 4.6. That would be here-ish. Times 1.15. That would be 5.29. So 5 and a little bit over a quarter. I'm going to say that's right there. Next one, times 1.15. That's given me 6.08. So this point would be right at a little bit above 6 times 1.15. And I get 7, pretty much. Times 1.15. I get an 8.04. So this is 8.04-ish right there. We can kind of see here that it's making a slight curve. It's not a really steep curve, but we didn't expect a steep curve because the A value or the B value is close to 1. Now, if I wanted to go backwards, again, I would just take 4 and then divide by 1.15. And I would get 3.47, so about 3.5. So 3.5 would be about right here. Okay, so this one cannot be equal to, so it's looking like this one should be dotted. All right, so there's my dotted curve, and it says y is less than. Where is y less than? It's less than down here. Okay, so it looks like this whole section should be our solution area. Well, 0, 0 is in our solution area, so let's fill that in. If I plug in a 0 here, less than or equal to 1.15 to the 0 power is 1, and 4 times 1 is 4. And 0 is less than 4. So that means this section down here is my solution area. Next one says y equals -3. That's interesting. All right, this is actually a line. What we've got here is this is a line because it's in slope-intercept form. The -3 is b, but where's the x? The x is nowhere because m is 0. 0 times x is 0, so that's why we don't see an x here. So, if my y-intercept is at -3, down 1, 2, 3, and my slope is 0, that means it's going to be a flat line. Is there another way to do this, Mr. Holcomb? Of course there is. Here's what you can do. You can plug in an x number into this equation. I don't know, let's plug in 1. Well, where do I plug in 1? Well, nowhere. What does the equation say? Y is less than 3. What if I plugged in 2? Well, 2 can't go in there. What does the equation say? Y is less than -3. So if I plugged in 1, it still says y is -3. If I plug in 2, it still says y is -3. If I plug in -2, it still says y is -3. This equation says y is always -3. And since it can be equal to, we would make this one into a solid line. And so this one says that y is less than or equal to. So equal to is taken care of because it's a solid line. Less than is down here. Here's all my solutions. So we can plug in 0, 0 into this one. There is no x to plug into, so all I would get was 0 is less than or equal to -3. That's not true when plugging this point in. So that means this point doesn't belong in those solutions. Now the other one's the opposite. This one says that x is less than 2. Okay, so this one is not even in slope-intercept form because there's no y. So how are we going to deal with this one? On this particular one, if x is 2, so over 1, 2, what could y be? Could y be 1? Yeah, it could be 1 because there's no place to plug in the y over here. If x is 2, could y be 0? Yep, it'd be 0 right there. It could be anything for the y. As long as the x is 2, all these points that I'm plugging in here, x is 2 on them. Because this is 2, 0, 2, 1, 2, 2, 2, -1, 2, -2, 2, -3, 2, -4, 2, -5, 2, -6. Every single point here, x is 2. So this would be a vertical line. All right, now this one says that x is less than. This is different from all our other ones because these ones were saying y is less than, y is less than. This one says x is less than. Well, where does x get less than? It gets less than over here. There's where the x's get less. So this is where our solution is. Can we test a number? Yeah, let's plug in 0, 0 right here. 0, 0, I would plug in 0 for x and 0 for y. Oh, there's no place to plug it in, so I'll ignore it. 0 is less than 2. That's true. So that's why this is where our solution is. Last problem for this one. This one right here, we're supposed to make the inequality. Okay, so I see that this is a dotted line. Okay, that's good to know. I see that it's a line, so I should have y equals mx plus b. And then I can see that it's shaded below the line. So that tells me right off the bat, I'm going to need the less than sign. Not equal to, because it's dotted. So it's less than, y gets less than down here. So y is less than. Okay, now I need the slope and the y-intercept. Okay, so I can see there's a point right here and a point right here. It looks like it goes down 1 and over 1, 2, 3. So my slope must be down 1 over 3, negative 1 over 3x. And then what's the y-intercept? The y-intercept's right here, negative 1. There's my inequality for this one. It's less than or equal to because it's shaded below and it's dotted, so we can't have the equal to. It's just less than, sorry. Just less than, not less than or equal to. I found my slope by just picking 2 points and going down 1, making a slope triangle right there. And my y-intercept's right here at negative 1. That's all I got for you. It's an easy one. Math hard. See you later. Bye.